Okay, the objective of this demonstration is to develop the algorithm to calculate the roots of this quadratic equation. Uh, we know from very early classes that x can be calculated with the formula minus b plus minus b squared minus 4 times ac and divided by 2a. So if the term which is under the root, so if this is positive, then we expect we are going to have positive real roots, right? And if it is uh, 0, then we have the equal roots. And if it is less than 0, then we are going to have the complex roots. So we, in our calculations, after reading the ABC coefficients, so inputs for the algorithms are values of A, B, and C. A, B, and C, right? So for the time being, I have considered ampersand as equivalent to and, but this is not the technical standard. Okay. So the core of the algorithm, which determines roots to be real or complex, so it is b squared minus 4ac. So it is called as discriminator. So discriminator, right? So we are going to encounter this situation if discriminator is greater than 0, then we have the distinct x1 and x2, and they are going to be real and distinct. Distinct. Okay. There is the other condition. If discriminator is equal to 0, then we have the situation x1 equal to x2. However, they will remain real and their value would be b minus b divided by 2a. The third condition is if the discriminator is less than 0, so we have to have the square root, and there is going to be the complex number, right? So in that case, we have to calculate it differently. So we will have the complex numbers cx1 with the real part as minus b by 2a, and plus we will calculate as square root of minus times discriminator, right? Well, this should be calculated separately. Well, we should say that real of this one, and this will be considered as complex component. So we will have the complex part for the first root as the square root of minus times discriminator divided by 2a. And the second root, so here the complex c1 and complex c2 number will have the real part of c2 as again minus b by 2a, and the complex part will be the negative of this number, which is calculated as minus discriminator over 2a, right? So this needs to be programmed, right? Let's write that one in the flow chart structure. So we will start the algorithm with the oval shape. Then we will represent the inputs with the parallelogram. So inputs are A, B, and C, right? Now, if I make a check, for example, if A is equal to 0, right? So I'm going to write a condition. So with the diamond, right? So, okay, well, I must have some process over here. So after reading, so if A is equal to 0, then what's going to be the equation? Equation will be then bx plus c equal to 0. And then the solution will be c divided by b with the negative sign, right? So if this is the situation, then then so this is going to make a branch. If a is equal to 0, then the calculation would be x equals c by b, right? And then it will go to the end of the program. I will construct that one later. Okay. And if a is not equal to 0, so this was for yes, and this is for no. And now we have the option for the discriminator. We will calculate the discriminator, right? Which is b squared minus 4ac, right? So we are going to have experienced the situations. So let's write the first one. So I say discriminator is equal to 0, right? So in this case, if this is true, right? Yes. If this is true, then our calculation will be x1 equal to x2, and it is equal to minus b over 2a, right? If the discriminator is not equal to 0, then we have to consider two conditions, right? So either discriminator is greater than 0, or the discriminator is less than 0. So if it is greater than 0, then we will calculate distinct x1 and x2, right? So we will get the distinct values, and in case it is less than 0, then we have to calculate the complex roots cx1 and cx2, which are of the form a plus iota beta and alpha plus iota beta and alpha minus iota beta, right? So the complex numbers can be represented in the programming language. So after that, we will have the junction. So all three would be combined. Okay, discriminator greater than 0, discriminator, okay, yes, and it goes here, and this will also be joined over here. And then finally, there is going to be the output accordingly for real roots and all that. And after that, there is going to be the oval to say stop. The algorithm has been implemented in a separate video, so I hope you can follow that one very, very easily. So that's the whole algorithm, right? Starting from the values. Okay. Yeah. So I hope we have discussed everything over here. Start and ABC. If A is 0, then we don't need to go for the quadratic equation. So we will directly get to the end, right? And if A is not equal to 0, then we will go for the calculation of discriminator. And then we will see if discriminator is 0, then the equal roots would lead to this the end of the program. And if discriminator is not equal to 0, then we have to look for the possibility of getting real roots. So here, these were the real roots. And in case discriminator is less than 0, then we have to explore accordingly the complex root calculation. So with this point, we are ready to deploy it on a computer program. So I leave that one as an assignment for you to explore the facility. And in case you require assistance, you can look for my video over the internet.